So this video is going to talk about simplifying and evaluating radicals. So when we first learned to simplify radicals, we just had numbers under them. So what we did when we had a number under there was we made a factor tree. So factor trees, we just take 45 and divide it by anything it can divide by. So you can just Google factors of 45. And one of the things it divides by is 5. So 45 divided by 5 is 9. So we put the two things that it divides by. Now, 5 is a prime number. It doesn't divide by anything else. 9, though, is not a prime number. It divides by 3 and 3. Now, remember when you're making this factor tree, you don't want to put any 1s over there. So only numbers besides 1. Then when you get down to this where they're all prime numbers, that's called the prime factorization, and that's how you know you're done. When that happens, if you have just a number that only occurs once, that number is going to stay inside your radical. This is a square root, so when we have a pair, they go outside in front of a radical once per set, because we're taking the square root of that. So what this would look like is there's a 2 on the outside, so we would bring that down. The 3 has a pair, so we write it one time. And then we have the square root sign for anything that did not have a pair. So that 5 is what goes there. Then notice how I had multiplication. So anything, if we have two numbers outside, we multiply them together. If we had any numbers more than just the 5 inside, we would multiply that together. And then that's how we would get our answer. So what we're going to do today is build on that. So when you have a radical, let's say I have a radical that looks like this, the index right there, that little number in kind of the armpit of that radical, tells you how many items have to be in a group to escape that radical. So every time we do one of these, the first thing we are going to do is circle that index. Circle that index, and you can write yourself a note what that index is. Circle that index so you know what it is. And then you look underneath the radical and you make the factor tree. So we need to do a factor tree of 64. So 64 divides by 8 and 8, and then I just kept dividing until I get down to 2's, which are prime numbers. That's when I stop. Now notice on this one, the index is 3, so that tells me I need 3 in a set. So I have a set here, 3 that are the same number. So that's going to be written on the outside. And I have a set here, so that's going to be written on the outside. Now notice there's nothing left in my factor tree, so do I even need the radical? No, I don't, because there's nothing left to put underneath it. So I just multiply 2 times 2, and my answer is 4. On this next one, what is the index? Well, the index is that number there in the armpit of the radical. The index is 3. So now I do a factor tree. I'm going to pause it while I do this. So 40 divides by 10 and 4, and then we got this prime factorization here. Remember, all of these numbers are prime. They can only divide by themselves in 1, so that's why we stop there. So I'm looking for a set of 3. Do I have 3 of the same number? Yep. I have 3 2's, so that's going to go on the outside. But on this one, I still have a 5 left over, so I have to put that radical so that the 5 goes under there and put it there. Okay, so now this actually is not the right answer. Some of you are going, yeah, Mrs. Black, it is. We put the 2 on the outside and the 5 on the inside, and that's all you told us to do. You're right, that is all I told you to do. But the thing is, see how that was a cube root? When there's not a number written in the index, it's a square root. So this is a different root. So you have to put that index in there. So don't forget the index. The number one thing people do wrong when they're doing this kind of problem is leave that little bitty number out of there. Okay, so we've dealt with numbers. Now let's put some variables in there. So assume all of these variables are positive. So the first thing we need to do is look again for our index. Our index is 3. So that means we have to have 3 in a group in order to escape. We have a number, 270. So we need to make a factor tree for that. Okay, there's our factor tree for 270. Now I also need to write out how many x's I have. So it looks like I have x to the third. So what that means is I have 3 x's. Y is to the 12th. So that means I have 12 y's. Oops. That bled into the other problem space, but that's okay. So what we do here is the same thing for our x's and y's. We circle sets of 3. So for all of these things, the numbers, the x's and the y's, I'm going to look and see how many sets of 3 that I have. So if I look at my numbers, it looks like here I have 3 threes. So there's going to be a 3 on the outside. Then I look at these letters. If I look at these letters, it looks like for my x's, I have a group of 3. So how many groups of 3 do I have? 1. How many x's are left after I'm done grouping? 0. So what that means is I'm going to take an x and put it out here. Remember, 1 time per set. And I'm not going to have anything to put underneath this radical. Don't forget your index. Okay, so let's talk about these two numbers real quick before I move on to the y's. See how there's a 5 and a 2? That 5 and the 2 stay under the radical because they couldn't escape. Okay, next I have the y's. So let's look at the y's. I need groups of 3. Here's a set. Here's a set. There's a set. And another set. Okay, so it looks like, how many groups do I have? 1, 2, 3, 4. 4 groups. How many left to stay under the radical? 0. There's no singletons that didn't get put in a group. So what this looks like is I'm going to write a y, and then however many groups I had, that's going to be my exponent. So it's y to the 4th telling me there were 4 groups of y's. And since I don't have any x's or y's left, I have nothing to put underneath this radical. Now we multiply everything together. 3xy to the 4th. That doesn't change, but under the radical I have 5 times 2, which gives me 10. So that's my final answer. Okay, next one, similar thing, except now we have division, but you know what? We're just going to ignore that. Completely ignore it. We are still going to just look really quickly. First thing we should do, look at our index. Our index is 4, so that tells me I need 4 things in order to escape a group. I need a factor tree of 112. So the factor tree of 112 divides by 8 and 14, 4 and 2, etc. I did realize while I had this pause that I had this was messed up. This should be x to the 12th, not x to the whatever it was before. Okay, so if I have x to the 12th, that means I have 12 x's. Okay, how many do I need to circle in a group? So in this one, when I have an index of 4, how many do I have to circle in a group? Hopefully you know that it is 4. So I circle 4 of those. Now my x's, I have a group of 4 here, and 4 here, and 4 here, and 4. Oh, that's handy. Okay, so my numerator, I had a 5 on the outside, so that comes down. Then over here on my numbers, I had a group of 2's, so that comes out of the radical. Under my radical, I still have a 7. And then in the denominator, I'm going to have x to a power. Do you know what power it's going to be? Count how many circles there are. That's what the power will be. X to the 4th. Did I put 16 x's? I sure did. Good grief, Mrs. Black. These x's shouldn't even be here. Put 16 x's. I'm sorry. Should be x to the 3rd. So as awesome as this is, it's not right. I have to multiply. So 10 with my 7 underneath and x to the third. Now I still did not do that right. Did anybody catch my mistake? Hopefully you did. Hopefully you noticed that I didn't put a 4 in my index in either place, and I have to have that 4 or it won't be right. Okay, next we need to talk about when we have negatives under a root. If you have a negative under a radical and it's an even index, so right here, if this is a 2 or a 4, like here it was a 4, 2 or a 4, then when you have that, you'll bring an I out, because remember, I is the square root of -1, and then you would simplify. So, like for example, if I had the square root of -25, that would give me I on the outside, and then square root of 25, and then you can just do square root of 25 in your calculator, which gives you 5, and then we put the I second, because letters always go second when we're writing our answer. Now, if you have a negative under an odd index, so like if there's a 3 or a 5 right here, like this example, a 3 in your index, then you just bring out a -1. So for example, if I had the cube root of -64, I would bring out a -1, and then I would do the cube root of 64. And you can actually do that in your calculator. If you turn your calculator, or sorry, in your phone, a lot of times if you turn your phone sideways, there will be a button that says like X and then a Y underneath it. You need to put 3, then press this button, then press 64, or maybe it's backwards, but I bet you can figure it out. So this would be -1 times, and then if I do cube root of 64, that is 4. So if I multiply those together, I get -4, my final answer. So when it's an even root, even index, you have an I. When it's not an even index, you just bring the negative out front. So on this one, one more thing. When there's no number in the index is 2 because it's square root. So that's the automatic index is 2. But if we have a different number, like here it's 3 and here it's 4. But here it's 2 because there's nothing written in there. So our index here, circle your index. Our index is 2. So we notice that this has an even index, and with that negative under it, that means we're going to have an I. So I know when I bring down this -3, this negative is going to give me an I. Then I just have to do square root of 40. So we make a factor tree for 40. 40 divides by 10 and 4, 5 and 2, 2 and 2. Okay, so I have an index of 2, so I circle 2 pairs. Oops. So I have -3 and I, and then my pair of 2's goes out front, and my square root still has this 5 and the 2 that didn't get to join a group. So I multiply all those together. The 3 and the 2 are both outside, so we multiply them together. So that gives me -6i. The I goes after, the I goes right in front of the radical, and 5 times 2 is 10. That one's finished. Okay, next one. First thing you do anytime you encounter these problems is circle the index. The index in this case is 3. So we know that 3 is an odd number. So since we have a negative under there, it's going to give me -1. So my 6 comes down. My negative that was in there, since it's an index of 3, that's an odd number, I get a -1 outside. And then I do the cube root of +270. Now, if you could figure out how to do that in a calculator or on your phone, that's awesome. If you can't, then make a factor tree like me. So 270 divides by 27 and 10, and then you can see that breakdown. So I need to circle how many at a time? Well, since my index is 3, I have to circle 3 at a time. It looks like I have 3 3s. 5 and the 2 are not going to escape. So I have 6 times -1, and then my group of 3s gets to escape the radical. But underneath the radical, I still have a 5 and a 2. And then when I multiply all of those together, 6 times -1 times 3 is -18. And then I have the cube root of 5 times 2, which is 10. Okay, next, find the roots or solve. When this says find the roots or solve, you will have either 2 answers or 1 answer. When you have an even index, we talked about that when it's like 4 or 2, you have to give both the positive and the negative answer. So you will have 2 answers. When you have an odd index, you just keep the sign from under the radical. So if it's negative, your answer will be negative. If it's positive, your answer will be positive. So in this one, I need to do the 4th root of 16 over 81. So what we can do is split this to be the 4th root of 16 divided by the 4th root of 81. So if I need to do this problem, first thing we do is look for our index. Our index is 4. So I need to make factor trees and circle groups of 4. So let me make those factor trees. So I'm looking for groups of 4. It looks to me like with the 16, I have a group of 4 2s. So since 16 was on the numerator, my numerator is going to be 2. And then for the 81, I had a group of 4 3s. So that's going to be my denominator. Now, if this index was odd, I would be done because we would only keep the sign from under a radical, which are both positive. But since it's even, since the 4 is an even number, we have to have both answers. Okay, so since the 4 is even, we have to put a comma, and then we have to put the opposite sign. So this is positive 2/3. Our other answer is going to be negative 2/3. The reason for this is because I don't know if this 16 is 2 times 2 times 2 times 2 or -2, -2, -2, -2. They both would give me positive 16. So I have to incorporate both opportunities. Okay, last few and then we're done. Okay, on these solved ones, these are where we have a power, an exponent, and we have to use a radical. So this first one says x squared equals 49. So what we do is we take a radical, whatever the index or whatever the exponent is, we put that as the index. So this is squared, so we're going to do square root. So we have x equals, and then what is our index? Well, the index is the same as the exponent, so the index is 2. So we have the square root of 49, so we make a factor tree. We circle pairs because the index is 2, so the answer is 7. But do you see that we have an even index? 2 is an even number. So since we have an even index, we have to also put -7. So you have 2 answers, 7 and -7. And on this one, I have x to the 3rd. So my index is going to be 3. That's a 27. So if my index is 3, I'm going to put a radical over both of these and a 3 in the index. So we're going to do a factor tree of 27. Okay, so what happens, I didn't explain this on the last one. What happens is this radical and the power cancel each other. So the radical and the power cancel each other. That's why we have to do a radical. So that leaves me with just x. Now this side, I have a group of 3s. So I have a group of 3s. However, did y'all see that there was a negative right here? This negative right here pops into my answer. So my answer is actually -3 because this is an odd index it keeps the sign that was under the radical. Okay, so since it was a negative 27, it keeps it. It doesn't need two answers when this is an odd number. It's only when it's an even number. Okay, next one. My power is 4, so the index of my radical has to be 4. Is 4 an even number or an odd number? Hopefully you know that it's an even number. So when I do the fourth root, I need to make a factor tree for 625. That divides by 25 and 25. So over here, my root and my exponent cancel, so I just have an x. Over here, I'm looking for a set of 4. So along here, see I have a set of 4 5s. So my answer is 5. But is 4 an even or an odd number? It's even, so I also have to have the negative. Please, please, please let me know if you have any questions.